So good afternoon, all of you. Today, in another group meeting, we have Harvey. Point to you.
Oh, okay. Yeah, it's kind of dumb. So today we have Harvey, who's a visiting PhD, final year PhD scholar from University of Malaga, and he's working on interpreting technology. And today he's giving the talk. So over to you, Harvey, for the next
Thank
one.
you. Here, okay. Thank you to all for coming, and thank you, sorry, for the presentation. I'm going to present the project, which is related to my thesis project, because my thesis is within the framework of a bigger research project, and I'm part of it. This is the provisional title of my thesis, Trends Interpreting Technology Development and How AI is Related. So the first thing, to give some context about all this, is what is going on in translation and interpreting technologies, to understand why we are focused on interpreters. So first, this is the main differences in the settings of the translators and interpreters work. The translators always work at the office or at home. Interpreters too, during the preparation of the interpretation. They can also work at home or at an office during the interpreting in remote environments. But the biggest difference is that translation is a long-time job. They have a schedule. They have days, at least a few days, depending on the job, to perform the translation, while interpreters perform also translation, but in real time and in speech. Interpreting is speech-based, and translators translation is text-based, which is suppose many differences in the features of the job. The big difference behind the resource they use during their work is that translators prepare some resources and they can use these resources during the translation, but interpreters, in most cases, this is a bit different now, but they can use these resources during the interpreting, so they have to study and prepare the topic beforehand. So this is the kind of technology they use. They rely on corpus and terminology, also in dictionaries and glossaries. They use machine translation, for example. These kind of common technologies that they use. The difference is that they use this technology in different ways because of these differences in the setting of the work. They have also CAT tools and guide tools, which are computer-assisted translation tools and computer-assisted interpreting tools. There is a big difference here because at first we can think of this as a category. Computer-assisted translation tools are all the technologies, all the tools that they use for translation, and the same for interpreting. But the thing is that there is a specific category of software tools that are called computer-assisted translation tools, which are unified platforms with all the tools, all the resources that they will need during the translation. This kind of tools didn't exist for interpreters. This is why my supervisor, the Professor Corpas, and my research group started the VIPII project. VIPII stands for Voice Text Integrated System for Interpreters. this voice text is highlighted because interpreters relies not only in text but also in speech. So it's a key feature to give voice-related interaction for interpreters. This project started in 2016. I started to work in it in 2018. So in the first, this was actually two projects. One is finished, and the other is an ongoing project. During the first project, we created a unified platform with all the tools the interpreters need. We analyzed the existing technology, existing interpreting technologies, and improve the filters, integrating all of them. And we started a second project. My thesis project is related to this second project to improve the system based on the feedback from the interpreters that are already using this system, but also keeping an eye on new research in AI and computer science. So first thing is I'm going to present the system, which is the main result from these two projects. It's computer assisted interpretive tool, complete tool that covers all the needs that the interpreters have. It's a web application, so it is multi-platform, and it's also adapted to mobile devices, so interpreters can use it even during the interpretation. It includes some features that are interacted through text and other that are interacted through voice. This system is organized in 4 big modules: the corpus and glossary modules, a complementary module with complementary tools or features, and a training module. These are the languages. The system is compatible with English, Spanish, French, German, and Italian, and we are now integrating Arabic and Chinese. Starting with the first module, the corpus module, the first thing an interpreter will need before the interpretation is to prepare on the topic. They normally will search on the internet or on other resources to retrieve text, to learn about the topic, to get key terms, extract terminology, to construct a glossary on the topic. We offer a tool that performs a simple web search. It gives the URLs of different websites related to a certain topic, and the user can select the web pages that they want and create a corpus with all the web pages. What the system do is extract and clean the text from the web pages, so the user doesn't need to do that. And then it performs a tagging of the whole text to ease the query of the corpus. Also, the system allows to use your own text. If you have, for example, a PDF document about the topic or something that the client gives to the interpreter can use upload that document to the same corpus and add it to their own knowledge base. Once you have your own corpus, you can query it. We offer different possibilities. And in this example, we see a pattern query of adjective plus noun with the term energy. This is the result that the system gave. All the possible multi-word terms, adjective plus noun. Here, the user can directly select the terms they want and create a glossary in the upper bar. With those terms, the user can select all the languages that they want the glossary in. So in this case, is English, but the system will perform a matching translation from English to all the language the user select. Other possible queries are concordances to see words or terms in context, engrams, frequency list of terms. The term candidates is mix between the patterns query and frequency list. It's like a faster terminology extraction feature. So once the user retrieve the key terms from the corpus, they can manage the glossary in the system. As you can see, these are matching translated terms. So we always recommend the user to review and correct all the translations. But this tool also includes direct links to resources like word reference or linguistic, so they can search the term on these places directly and select different translation, different equivalents. These tools also offer the possibility to export the glossary in Excel. They can also import their own glossaries, split and merge existing glossaries. And this is a fast query tool for the glossaries. This is supposed to, well, it's designed to be used during the interpreting. So they select one glossary or the glossaries they want to use during it, and they can search on all the glossaries, writing or even with voice. They can say a word, for example, and the system will search the word in the glossaries and highlight it, all the findings. Okay, and also the training module is to generate exercises for practice. This is an example following the example of the glossaries. It's a glossary exercise. The user can select the glossary they want and the configuration of languages, and the system will generate few examples with the field to write or to say the translation. This is all red because I simply click on check to see that it automatically corrects the exercise. We offer also an anticipation exercise, which is fill the gap kind of exercise. The user can select a corpus and a glossary, and the system will retrieve random segments from the corpus and put gaps in key terms from the glossary to practice the anticipation of these words. Also a numbers exercise. Numbers are really hard to translate during interpretation. It requires a high cognitive effort to think of the number in the target language. So we offer customization of number exercise, which you can both generate random numbers in text or in number, also with or without decimals, these kind of things. And the site translation function is a kind of interpretation practice, but translating text. The user selects a parallel corpus, and the system selects some segment from the corpus and generates the text in the origin language, and the user have to translate in real time using their voice to the target language. This is all some of the features that are based in NLP or AI techniques. Some of them are included or integrated in the existing general modules on the corpus or glossary modules or in the training. Some others are part of the complementary module I told you before. We have a name entity recognition tool specific to paste a text or upload a document and retrieve the name entities. But this is also integrated in the corpus tool. Also, automatic summarization tool, and matching translation and speech recognition. This is for note-taking assistant. This performs automatic speech recognition in real time and translates the text. The most important feature of this is that it highlights name entities and terms from the glossary that the user selects. Most interpreters don't really want the transcription in the screen. They only want the key terms, name entities, these kind of things. So they offer the possibility to select with output the user wants. And we are already implement some improvements in the system during the second project, during the VIPII. But these are some of the new developments that we are currently doing. The integration of parallel corpora. Normally, well, both translators and interpreters need parallel corpora, need parallel data. We only offer for now monolingual corpora, so it's not enough for them. Also multimodal, which is corpus that includes audio and video, not only text. Shared glossaries. This is a simple functionality, but they really want to share their glossary with other colleagues or to do a collaborative work in creating a new glossary, for example. We are improving some functionalities like machine translation, summary generation, the entities recognition, also automatic speech recognition, including new models, evaluating new models to improve the performance of the system, and also more type of exercises for training and improving the possibilities of the existing exercises. So related to my thesis project, what I'm doing is to explore the possibilities of new technologies to improve this system, and what we need to pay attention to, what we need to integrate, what we need to do to improve the system. I'm going to present some results, some conclusions from 3 papers that are already published. The first thing I put my eye on was LLMs. Everyone is now using LLMs, so we need to pay attention to them and see how we can integrate them in the system. Interpreters are already using it, like many other professionals, for terminology extraction or compilation, for summaries, translation. So in this paper, we select a set of 16 functionalities from the Kai tools and see if ChatGPT and Gemini can perform them or not. This is maybe a bit outdated because we wrote this in 2 years ago, so maybe now this table shows which features they can perform and which not. Maybe this is different now, but most of the features are possible. The models are possible to perform them. So the conclusion is that LLMs are not only as good as Kai tools, but in some cases are better than existing Kai tools. We need to pay attention to them and most important flaw of LLMs is that they are not designed for real-time applications. At the time, I don't really know now if they can perform better in real time, but they're not really designed for this kind of tasks. So we have to pay attention where we can use them or where not. But generative AI can improve guide tools. This is the important thing. After that, as you can see, terminology is really, really important for interpreters as well as for translators. So what we did in this second paper is to compare existing guide tools relating to the terminology extraction and management and see if they can cover all the needs of the interpreters. The context of this paper is that guide tools are better than traditional terminology extractors, but are not perfect. What we did is select 3 guide tools. There aren't many really complete and as I said before, guide tools are unified platforms. There aren't many software in the market that can be categorized under a guide tool, that this kind of unified platform. So we select only 3. From these 3 tools, we selected a total of 31 features. In these features, we included some others from the literature that we know that interpreters demand, interpreters need these tools to do. And what we found is some of them are not included in existing tools. So these 6 features are not included in any existing guide tool. So it's the kind of things we need to pay attention to. The first thing is a simple feature, like they really need a communication application during the interpretation. Most interpreters work in pairs, and they use applications like WhatsApp to communicate during the interpretation, and they want to this kind of functionalities to be integrated in the same tool that they are using for all their work. The second is also simple, but is not performed by any existing tool. Is domain detection and adaptation. If you have an existing glossary, the system should know which is the domain of the glossary and adapt the terminology extraction to that domain. Also, quality estimation to when a system performs automatic terminology extraction to have a general idea of how good the terms are, the glossary is. Also detect patterns in speech. This is real-time feature, but also for preparation, interpreters use existing videos or speech to prepare the interpretation. They want the tools that detect certain patterns to prepare better for existing domains or existing case. Matching interpreting. This is what we know also as speech-to-speech translation. We can say that matching interpreting really exists because interpretation involves many more things than simple translation. So they really need a kind of matching interpreting to assist them, but also to cover certain situations where they aren't prepared, or for example, when for some language pairs it's hard to find existing interpreters, this kind of situations. The last one is also simple thing is to be able to save the notes you make during an interpretation and exporting it to use them in another tool or to send them to another device. And the last paper in this last work, we explored the possibilities of speech pre-processing for real time, but also for preparation to extract this is for terminology extraction directly from speech, or to for speech translation. What we found is that we need the existing ASR systems and speech translations to give more information, not only the transcription of the translation. So what we propose here is a multitask classification that performs 3 detection tasks, which are prosodic boundary detection, speaker change detection, and accent detection. This is the architecture of the model. It's based on Web2Vec block as the feature extraction, and then this feature extractor generates representations that are used in the classification of the 3 tasks. So we perform training on an existing corpus of American English corpus, and we got this final results with a balanced training on the 3 tasks of the model. And the key of this model is that it doesn't need text information. It relies on acoustic information and timestamps. So it's not a big model. It doesn't require many information, many data size, big data size. And it's the first multitask model that performs these 3 specifically tasks. These are the 3 references of the papers. That's all. If you have any question, if you want more details about the system or whatever.